Everyone. A very warm welcome. Those who would like to discuss the natural gas processing with me. Uh, Today is the first introductory lecture, and we will be talking about the just as a general introduction about the natural gas. Uh, Natural gas is right now used worldwide, especially it is needed for heating purpose where there's a very cold weather and natural gas is really helpful in for those countries to provide the heating to those homes and places there. The second use of this natural gas is the cars. We have as compressed natural gas (CNG), and many Asian countries are using this natural gas for uh, using in transportation purpose. Then for the industrial purpose, many of the industries where there's a lack of electricity by the government, they are using the power generators, or we call them in as a term gensets. They are gas based. So this gas, and it is more clean, it is cheaper than the crude oil, and is very much important, and is useful for not only for power generation, for heating purpose, for transportation. So it's a complete industry, and there are many countries, including the Qatar and Russia and the US. They are exporting the gas to many Asian countries and European countries around. So let's start with it and see how it all goes. Okay, the outline for this today's presentation, we are going to discuss about the sources of natural gas and what kind of composition of natural gas reservoir could have, and how do we classify them, what are the principal products that we can get, and how we continue. So first of all, we would like to look at the history from this about the natural gas, when actually it started commercially. Well, the first well was in 1821, as you can see here written, and they just tried to use it for the lamps nearby. That was the original purpose. They started around one long time ago. So 1821 is the commercial use of natural gas has started, and so on. And after the World War II, the long distance pipelines are formed, and the it becomes a complete industry where it can be transported for power generation and so on and other purpose. Look at the pollution level of natural gas, oil, and coal. You can see that the the overall all the CO, carbon monoxide, nitrogen oxide, sulfur dioxide, the all the ratio and values are less than oil and coal. So it is much more cleaner than the oil or coal. Coal is very uh, not environmental friendly, but natural gas is an environmental friendly gas one. Look at this picture. Actually, it's 2005. It's not really new, but still look at the use of crude oil. After the crude oil, the natural gas is 23.5% of the worldwide uh, use of energy. It has natural gas, the share of 23.5%. And then we have some after that is the coal. But as we are proceeding ahead, the coal use of coal is declining because of its environmental hazards. We are mostly concentrating on the crude oil and the natural gas, and now, as you know, that renewables are coming in the picture. Now look at the reserves that we have of natural gas around the world. So Russia, as you know, that they are at the top. Then Iran, Qatar, Saudi, UAE, United States, Nigeria. So these are the top 10 countries where we have proven natural gas reserves. And you see that Iraq is at the top also. They have lots of gas. But the problem here in Iraq is that we don't have the big gas processing facilities, and we cannot transport this gas to anywhere unless we have the removal of H2S and CO2 out of it, and we make it commercially viable to send to other countries by using the transport by using the trucks and so on. So there are many ways to transport this natural gas. We will discuss them in the coming lectures. And as you know, that LNG is the very popular method nowadays, which Qatar is using nowadays to sending their gas to all over the world. So right now, Russia, Iran, Qatar, Saudi all these countries have a lot of reserves, and these are as of 2005. And I'm sure right now, if you look at the latest pictures, these countries have more proven reserves right now. So the first thing that you need to know that like what is BTU? This is the first question, and we are going to talk about the gas composition, gas processing. First, you need to understand that what is the BTU, and BTU stands for actually British Thermal Unit, and look at it. What is the physical significance of this British Thermal Unit, so that we can proceed then further.
What is BTU? BTU stands for British Thermal Units. Why do I need to know about it? It is the measurement of how much energy is needed in order to heat your room. And now for the science bit. 1 BTU is the amount of energy needed to raise the temperature of 1 pound, that's 0.45 kilograms of water, by 1 degree Fahrenheit, that's 0.55 degrees Celsius. Remember, not all radiators are created equally.
So here we got our answer that the 1 BTU actually is the amount of energy raised to raise 1 degree Fahrenheit for 0.45 kg of water. So this is how much energy is needed to warm your room. So that's why it is important to know about the BTU. Now let's look at the Kurdistan Gas Reserves, and the report was published in 2015. And according to that report, the Kurdistan region, as part of Iraq, has 50 billion barrels of reserves of oil and 80 billion barrels of unproved reserves, in addition to 8 to 10 trillion cubic feet of natural gas reserves. These figures put Kurdistan in the 8th place in the world for oil and gas reserves. So we have lots of reserves of gas here in Kurdistan also. If you go to any oil field here in Kurdistan, you will see they have lots of flaring going on, and they are flaring the gas because they don't know what to do with it. They cannot transport it, they cannot process it, and here is the problem of H2S is a lot. So what they are doing, they are just burning the gas, flaring the gas, and not really processing it. So the future of Kurdistan region is on the gas also, and it can be a game changer for the economy of Kurdistan. So for example, if they are exporting the oil, as well as if they start exporting the gas, they are going to be much more economically better, and so on. Now let's look at the another two terms. What is the cubic feet? Because we are going to talk about the standard cubic feet of gas. So let's look at it. What is the standard cubic feet? And these basic terms are
the cubic foot of water. 1, 2, 3, 4, 5, 6, 7, and almost a half a gallon of water. Wait for it, here you go. 7.48 gallons of water. 1 cubic foot of space, 12 inches height, 12 inches wide, 12 inches depth will hold 7.48 gallons of water or gas. 12 inches height, 12 inches wide, 12 inches depth. So again, 1 cubic foot of space can hold 7.48 gallons of water. That is the volume, and the weight of this volume of water is approximately 62.4277 pounds.
So the amount of gas that can be held by 12 by 12 by 12, width, length, and height should be 12 inch, and whatever gas it comes is the cubic feet. Now let's look at it. How much is the the basic terms that you need to know about. Now, as I said, the use of this natural gas, where you can use it. This gas, natural gas supply, if you process it here in Kurdistan and send it to all over the world, this can be used for the residential purpose, especially in the regions where temperature is -30, -20, -40. So these people, these places needs a very good heating system, and gas can be used to provide a good heating purpose. So they are using for the residential purpose a lot. Then the commercial, as I said, for the power generation. Yes. So the for the this natural gas can be used for the fuel of car also, as a fuel for car also. As you know that there are many countries that are using this natural gas for transportation in normal home cars, like Asian countries like Pakistan, India, and many other countries. They are using this compressed natural gas to fuel their cars and run their cars. At the same time, there are many countries who are facing problem for electricity. So this gas can be used to provide the electricity for those industrial units as well as. As. At the same time, this natural gas can be used to run the power plants. Here you can see. So here in Kurdistan, we have two power plants that are run by this gas, and this gas is provided by the Dana gas here. So there are many sources of natural gas here in Kurdistan, uh, everywhere in the world actually. Well, we have two kinds of gas reservoirs here. One are the associated gas reservoirs. I mean, we call them combination drive also, where oil and gas exist together. But at the other side, we have reservoir which has only gas, or sometimes it has gas and water. So we have associated gas and non-associated gas. So whatever plant we are going to design, it has to be based on the type of reservoir we are producing. If we have an associated gas, it goes through a different process. If we have a non-associated gas, it requires a different kind of a plant. So we are going to discuss both sides and that what is needed in order to achieve that. Here you can see a general diagram for the gas processing. Here, for example, we start from here. Here you can see we have gas, oil and water. We want to produce the gas. So we put our well in the gas zone. We start this gas, gas well then goes to the separator. From the separator it goes to the field treatment processes. We compress this gas. We treat this gas here. And after the gas processing is treated, we obtain these products. Natural gas, goes from here, and this treatment system is related with the natural gas processing. This fractionation system is to deal with the oil. For example, this oil, if you are producing, this oil is actually goes inside this refinery, and they we obtain those products whatever we have here. But in this gas processing, we produce this gas, we connect them all together using the manifold. This manifold then goes towards the compression. We treat it. We you whatever treatment processes are. These treatment processes are depending upon the composition of this gas. For example, this gas might have CO2, so we have to remove the CO2. But this gas might not have nitrogen, so we don't need to put the nitrogen removal unit here. This gas may have H2S, so we have to put the H2S removal here. This gas may not have mercury, so we cannot put any any plant to remove the mercury. So this plant design, this treatment system design is completely based on what composition of gas you have. If and that's how we design these treating system, and we will discuss in the coming time about this the gas processing. Let's look at some of the natural gas composition around the world. Here you can see that we have Canada, Western Colorado, Southwest Kansas, usually the United States field, and Canadian fields we are talking about here. Here you can see that in Canada, we have lots of 77% is methane. And this is what we are interested in. When we talk about the natural gas, we are definitely talking about the methane gas mainly. Here you can see that propane is 3.5, 6.6, 1.7. So we have to remove this nitrogen, carbon dioxide, H2S, and rest all, if we can remove, they are in small quantity. If we remove them, we don't remove them, this is a question, because it depends on, is it beneficial to remove these small ethane, propane, and butane, or not. If it is not beneficial, I mean, it does not give us extra money, then we should not waste time on it. But if it gives us these some more profits, then we go for it. This is the first thing. For example, here in the other one, the Western Colorado, you can see that the gas is on methane gas is only 29.98. You can say 30% around the mole percent is. But on the other side, it has a lot of CO2. So we have to remove this nitrogen CO2, and they don't have H2S. So in this plant, we have to remove this H2S. But in this plant, we don't need to remove the H2S because there's no H2S actually. So we design our plants based on what is the composition of the oil we are getting. That's the main objective. So we look at the composition. We have the composition, then we look at it like what actually, and also the outcome. What the customer needs. What are the requirements of the government or wherever you are selling the the this purified natural. And now let's go further and see what is going on. What are the important impurities that we need to remove? And first of all, the sulfur. Okay, sulfur is not only the toxic, but it can take lives also. So that's why we have to remove this elemental sulfur, or it is in many forms H2S, elemental sulfur, and mercaptans. We have to remove this H2S. This is the most important part. And then after the H2S, the water, because the water is the main cause of dropping the heating value and main cause of corrosion also. So we have to remove this uh, water here from here. Then there are metal traces, mercury. This mercury may be present in some gases and may not be present. And so this depends on, but this is one of the impurity that gas reservoir may have. So we have to remove this uh, impurity also. So for example, this carbon dioxide, Colorado 80, H2S, this has to be removed and so on. Then we have some other impurity like oxygen. Well, this oxygen is a major cause of reducing the corrosion in the pipeline. So we have to remove this oxygen, because if the gas is oxygen, then all pipeline will be corroded and it may cause uh, leakages in the pipeline, and all gas will be gone, and environment will be affected. Then government will be angry, and there will penalties. At the same time, we will lose the we will lose the product. So we don't want to remove to do cause the corrosion. So that's why we remove this oxygen level at the same time. Well, one of the ways to remove the methane is from the coal bed. Usually, the Australia is working on this coal bed methane, and these bed methane reserves mostly can be removed, can be used to extract the natural gas from it. And Australia is one of the major country which actually removes this natural gas from the coal bed methane. Actually, coal bed methane is the methane gas which is in the coal reservoir, which is the part of coal reservoir. So every coal reservoir has a small amount of methane gas trapped into it, and when we remove the coal, we remove this natural gas also. So this is uh, basic natural gas impurities that we are talking. Yes. So as I said that we have two kinds of reservoirs uh, in 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 this. Many companies out there, we have two different kind of reservoir. One are the reservoir which has oil and gas together in combination, and then we have reservoir which are exclusively dry gas reservoir, which does not have any richer content like liquid hydrocarbons. But when we have hydrocarbon, when we have more than methane, propane, when we have the gas with propane, butane, hexane, heptane, so on, well, we call it the heavy rich gas, which it because it has the heavier hydrocarbons into it. Now, these hydrocarbons, well, it depends on totally economically. Uh, it's an economic decision to remove those liquid hydrocarbon from the gas, because if the gas does not have too much hydrocarbons, then what is the point to process it? Because maybe the operating cost is more than the profit you are going to make. So it has to be, considering the economic cost, the operating cost, and the capital cost. When we have all these costs together, then we can decide that whether we can remove the liquids out of it or not. But sometimes we leave them intentionally, because sometimes, for example, if the gas has nitrogen or CO2, they reduces the heating value, and the higher amount of heavy liquid hydrocarbons may increase the heating value of the gas. So if the heating value needs to be maintained, then we add the heavier hydrocarbons so that we can keep the gas at the standard conditions at the same point. Now, for example, what when we talk about the gas processing, what components gas could have? So gas might have methane. Methane, this is what we need. It could have H2S. It could have, it should CO2 or nitrogen or helium or water, ethane, propane. So these all components could be the part of natural gas. And what we do the processing. Once we remove the processing, we separate the water, helium, nitrogen, we separate all these products. Once we separate these products, we have a methane gas which directly goes to the pipeline and to the customer. They can use this gas for power generation, for residential purpose, for driving the cars, and so on. And on the other side, when we have the liquids, if they are economically viable, then ethane, propane, butane, and natural gasoline is recovered from it. So methane is the principal component. Actually, all this natural gas processing is about the methane. And this methane gas is used as a feedstock for many industrial chemicals, principally ammonia and methanol. And then we have the ethanol, ethane, that is also is part of the gas, and we use it. Propane and butane actually considered as a liquefied petroleum gas. And this gas is also used here in Kurdistan in the cylinders, and we use it for the cooking purpose here, this propane gas here in Kurdistan. Now, when we talk about the natural gas processing, what we are looking for? We are looking for example, the hydrogen sulfide has to be 0.25 to 0.3 grams per 100 SCF, standard cubic feet. Should not be more than that. And these are the minimum, maximum capacity of the contained that should be in the natural gas. Otherwise, we have to remove. If there is H2S or water vapor or oxygen more than that values, we have to remove them. And make sure that your major component is methane. At least should be 75% mole percent. As you know, if the methane, because you will sell this gas on the price of methane, so make sure that the it should not have H2S sulfur, because they will reduce the price of the gas you are selling. Another important characteristic that is important here is the heating value. The heating value, you have to maintain 950 to 1150 BTU per SCF. And we discussed already what is BTU. BTU is the British thermal unit, and amount it, how much energy you need to raise the temperature of the room. And SCF, standard cubic feet. I mean, how much gas can come in a standard cubic feet means 12 by 12 by 12 inch of a box. So whatever gas you are sending, it should be free from the liquids, hydrocarbons, and so on. Then let's look at, okay, then the combustion characteristics. The most important, the characteristics of the natural gas is the heating value, and heating value actually defines the 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 price of your gas also. If the heating value is low, the gas will be cheaper. If the heating value is higher, then the gas will be more expensive than the cheaper one. So heating value is the main reason. And sometimes the customer requires a very high heating value, because sometimes they want to run a process where high temperatures are needed. In that case, a good heating value may work. But if the heating value of your gas is not good, then they may reject it. They may not like it, because the heating value is not going to serve their purpose. For example, they need the gas for the steel mill, and where they have the furnace of thousands of centigrade of temperature is needed there. So in this case, if you cannot provide them a high heating value gas, they will not accept it, and of course it will be, a problem for if they buy the steel mill, they cannot maintain the temperature they need. That's why the high heating value and lower heating value are very important when we sell the gas. At the same time, there are many impurities that are reducing the heating value of the gas. For example, CO2, nitrogen, water. These are the main impurities, we call them, that reduces the heating value, and we must actually uh, remove them before we proceed further. Now we have a question here, and the question here, we have to remove this gallons per minute. How many liquids of gallons per minute we are producing if the 1000 SCF of gas we have? Yes. So here our question is, we have to calculate the gallons per minute of the Alberta gas, and this is the composition given. which is it has helium, nitrogen, CO2, H2S, methane, ethane, propane, butane, pentane, and heavy hydrocarbon. Its mole percent is given here. As you can see that mainly it has 17% is the ethane, 22 2 mole percent, 77% is the methane here, 6.6% mole percent is the ethane here. So these are the major components here. But it has some propane, butane, and pentane and heavy hydrocarbon. We have to find out that how much liquid in gallons per minute they are producing. So what we do in this case, a pound mole of gas at standard condition, this has 379.49 feet cube of volume. So first we have to look at the 1000 standard cubic, how many pound mole it has. So it has 2.635 pound moles it has. And what we do, and then we find out the gallons per minute, gallons per mole here, and then finally the gallons per minute that we have. So total we have 4.338 gallons per minute of of Alberta. Yes. So these are the combustion characteristics that we have to be careful for, and we make sure that the gas we are processing should not have any water, should not have H2S, should not have CO2, should not have nitrogen, should not have helium or mercury. So these impurities has to be removed before we commercially sell this gas onward. So this was an introductory lecture. We just discussed about the generally the natural gas, what are its uses, and what are the components, what are the impurities that we have to be removed, what are the maximum traces of component that we can keep in this natural gas, and we talk about the characteristics of combustion. We talked about that the heating value plays a very major role in selling those gases. So that's the end of the first lecture, and we look forward to I look forward to see you in the second lecture. Thank you very much. If you have any questions, you can contact me.